SkySpark is an analytics platform that automatically analyzes data from automation systems, meters, sensors, and other smart devices in order to identify issues, faults, trends, correlations, and opportunities for operational improvements and cost reduction. SkySpark works with data of all types, whether it be live data from automation systems, smart meters, web services, or historical data from CSV files and databases. SkySpark can also be used in a wide variety of applications, including energy and resource management and reporting, monitoring-based commissioning, equipment fault detection, energy analysis, load profiling, facility benchmarking, and asset performance tracking. Visit SkyFoundry.com today and start finding what matters.
BASSG, Smart Buildings Distribution Company. BASSG is a distributor of Onca Labs Incorporated. Onca Labs is a smart building labs, focused on generating technology, with edge computing methodologies. Onca Labs, Edge Analytics Controller Line, contain controllers, indoor air quality sensors, and power meters, bundled with industry-proven analytics and clustering technology. Edge computing, with clustering, creates a paradigm shift, where controls, visuals, and analytics are bundled in single device, without sophisticated and legacy IT networks. Leveraging SkySpark's clustering technology, Onca Labs is able to upgrade firmware securely, update controls logic to devices, view, deploy, consume analytics. Onca Labs' security policy is Zero Trust Networks. Provisioning firewall rules, inbound and outbound, has been written within our architecture. Security patches can be applied to all devices with ease. Visit OncaLabs.com today.
Good afternoon, everyone, or morning, depending on what time zone that you're in. And thank you for joining today's webinar. Another thanks to SkyFoundry and BAS Services and Graphics for sponsoring today's event. I'm Sam Schwartz, and I'll be your moderator today. Want to go over just a few housekeeping notes before we get started and jump into things. We encourage you to submit questions at any time using the Q&A button on the bottom part of the player, and the speakers will address the questions after the webinar. The chat function is where you can make general comments and chat with attendees. And also, if you happen to be experiencing any technical issues during the webinar, please use that same chat function to inform the panelists, and our tech experts will assist you. Finally, in terms of continuing education credit, you will receive an email within 1 week with your proof of attendance. So today's webinar is utilizing a distributed data and computing architecture and analytics applications. A few words on our panelists. John PETZE is a partner and co-founder at SkyFoundry, the developers of SkySpark, an analytics platform for smart device and equipment data. John has over 30 years of experience in automation, energy management, and M2M IoT, having served in senior level positions for manufacturers of hardware and software products. ALPER ÜZMEZLER is an innovation worker and creative mind of BAS Services and Graphics and Onca Labs, merging Brian Frank's innovations seamlessly. Matt Schwartz is a mechanical engineer with diverse experience in building automation optimization and controls, commissioning, construction, and energy modeling. He's a recognized leader in designing and delivering turnkey building automation system retrofits and optimization projects. He has led the integration of data analytics platforms in new construction and retrofit projects, and he has delivered turnkey controls retrofits for multi-tenant commercial buildings, medical office buildings, university facilities, and more. And then finally, Jerry WEATHERHOGG is the lead analytics developer for ATS Automation, the Pacific Northwest's leading controls engineering and energy optimization company. He has developed in SkySpark for more than 8 years and has established over 30 remote clustered SkySpark instances utilizing ArcBeam technology. And fun fact, he is SkyFoundry's certified essential trainer and the inaugural 2017 Skyposium View Builder Bake-Off winner. So without stealing any more precious time from our esteemed panelists, I'm going to hand it off to John to kick us off today. John?
Thanks so much. Appreciate the opportunity to discuss this topic with the audience and help people understand the role of edge computing, distributed analytics, and what it is and why it's important. And I think what's really good about this presentation today is we've got 3 real-world examples coming after I provide some introductory comments. So I really want to start here. Just like controls, it turns out that the Internet of Things is actually a distributed computing challenge. You know, in reality, it's not possible to send every piece of data from every sensor to a cloud. It's not cost effective, and it's actually not even desirable. It shouldn't be the barrier to getting value from the data you have from your equipment systems and devices. And so you need technology that can work with the distributed and non-hierarchical nature of automation controls and sensors. And, you know, another way to view that is, in other words, the cloud, as valuable, as important as it is, it's not a solution to everything we need to do in the real world of buildings and the built environment. So let's talk about some of the key terms here. You know, what do we mean when we talk about distributed architecture, the edge, the cloud? So the term distributed architecture really means that we're going to deploy an application across multiple computing devices, multiple computers. Let's refer to them as nodes. And that way we're going to distribute the work of data collection, connecting to external systems, the work of analytics, calculation, and processing, and the work of control, and finally, presentation of results and information to the user. It's not all going to be on one device. When we talk about the edge, we're referring to the nodes that are out there running on equipment systems or very close to the actual edge equipment systems, the HVAC systems, pumps, fans, dampers. When we refer to the cloud, we are talking about software applications that are running on cloud-based platforms, Amazon AWS, Microsoft Azure, or IBM, Google, and others. So distributed architecture spans edge to the cloud. A couple of other terms that are important to us. You've heard probably the term mentioned in some of the intros, clustering. What we mean by clustering is connecting these distributed computing nodes into a unified system. So they don't appear as separate systems. The users can interact with their data, their analytic results, their reports, and their views as if they were working with a single system. So the complexity of how the processing was distributed is really hidden from the people who work with the data and the system. So we say we get to a seamless user experience, even though the computing and processing is spread over multiple processors. Another important term, when we have distributed computing, backup and replication of the data become even more important. And by replication, we mean more than backup. We're talking about the ability to basically save, store, and run a fully operational copy of one of those distributed nodes, so that operators can actually fully interact with the data, even if the true end node is offline at that time. And we've got a great example of that coming up in Jerry's presentation. So those are the what. Now let's talk about why any of this matters. So there are a number of compelling reasons why the next generation of analytics for the IoT really has to embrace the edge and the cloud. First of all, is greater fault tolerance. And by that, there's a number of areas we need to touch on. We're talking about data collection, right? The fact that we have a device close to the equipment increases the reliability that we're going to be able to collect the data consistently and reliably. For example, think about interruptions we've all experienced on Zoom calls and others over the past year, right? Well, if that interruption came when you're trying to collect data, you could lose that data. Well, if we have the analytics, compute, device close to the equipment, we get more reliable data collection. But there's also another side of that. Think about the person in a building and there's something going wrong with a piece of equipment. They're standing next to a big chiller or something else. They need to look at the data and the performance of that system. Can you imagine you're standing 10 feet away from a big device like that and the internet is down, so you can't reach the cloud, which is where the data is. You should be able to look at the data from the machine that you're standing beside. Well, when you have the analytics deployed at a compute node and right there at the edge, you'll be able to. Another important issue is called latency. We need to provide more and more real-time data acquisition, analytics processing, and we're now basing control actions off of analytics. That has to happen in real time. It can't be dependent on a connection to a cloud that may come, go, and it may have latency. There's even another example of this. It's not only latency, but there are things called constrained networks. Networks that when you try to transmit data over them, they either have very low bandwidth or they have other barriers like high cost. If you're going to connect over, for example, cellular modems, there's a lot of cost to transmitting data. You can't transmit all the data over those connections. But what you can transmit are the analytic results. If the analytic processes happen at the edge, the only thing that needs to go up over that constrained and possibly expensive network is the analytic result. And we see reductions in network traffic as much as 1,000 to 1 by doing that. Finally, there's security reasons. Many jurisdictions, customer types, they require their data stay on premise, whether it's to meet regulatory requirements for data staying in a certain jurisdiction, or they simply can't connect to an external cloud. There's also a key role that can be provided by the analytics actually acting as the in-building isolation for devices and equipment that work off protocols that aren't internet secure. So if we have this, there's some other benefits that come out of it. We can save engineering costs. If we are applying the same technology at the edge as we are at the cloud, we can eliminate the engineering work that's associated with setting up multiple different devices from different manufacturers that require different tool sets. We can also often eliminate hardware costs by eliminating or reducing the number of gateways or interposing devices and security appliances to get the data. And as we said, by providing a seamless user experience, we can meet the distributed computing needs without affecting the user needs and the simplicity of them working with their systems. And finally, the idea of replication is worth another mention. What we're talking about here is not a backup that can be unzipped and reinstalled. We're talking about an actual working copy of the last available data that can be transported to another location in the network so that operators can work with it live, even when the end system is not connected. So what's it look like graphically? So here's a sample architecture, right? Showing where applications run. So we have applications running at the cloud. Those icons there convey the concept of multiple servers at the cloud level, allowing us to expand to huge system sizes because we're distributing the computing across multiple virtual or physical servers. But if we look at the bottom of the graphic, we can see the icon inside the secure firewall on premise inside a facility where it actually acts as the security boundary to those other devices. Finally, up at the top left, we see the analytics actually provided on small, low-cost edge equipment devices, as we'll see from one of the other speakers here today, where it's actually on or performing the actual control of the equipment. So this allows us to meet our requirements for conventional cloud-centric models where we do want to and see benefit of bringing all the data to a cloud. It allows us to also meet the requirements where we have to be on premise inside that secure firewall. And we can also combine that with the cloud. And It meets the requirements for applications that have to operate at the edge. They have to have the low latency, the speed, the reliability, and the low cost of being embedded in a small low-cost device that's right on the equipment, collecting the data, doing the analytics, doing control and presentation to the user. So hopefully that's given us a little bit of background. Next, we're going to transition and have our following speakers actually show you real-world applications of how this is being done. And so, Jerry, I'm going to turn it over to you to talk about your interesting applications of distributed architecture for analytics.
Okay, thank you, John. At ATS Automation, we utilize analytics running on edge devices to deploy a range of solutions. It's the basis for our public-facing customer portal, which I believe most of our customers utilize. We also use it for multi-edge campus integrations and for distant edge accessibility, where I don't know of any other solution that could fill that role. Next, please. So our public-facing customer portal, which internally we call LiveSpark, this is the primary access point for all our analytics customers. It's a cloud-based cluster consisting of a single portal, LiveSpark, connected to 32 edge devices and counting. And that number is only going to grow. It's a hub and spoke approach, utilizing secure network technology to ensure reliable connectivity and data transmission between LiveSpark, our portal, and the edge devices. Using edge devices provides for easy access for our customers. It's a single one-stop shop, and also for deployment of updates and upgrades through provisioning. Customers are restricted to their own projects. When they log into LiveSpark, they only see their own project. They don't know that there are many other projects on this portal. So they're in their own walled garden. And our cluster connects to edge devices, big and small. We have analytics running on rack servers, on virtual machines, and on Raspberry Pis, and even some of the Anka Labs devices that ALPER produces. Next, please. You can also set up clusters within a customer network. These are multi-edge campus integrations where you have a site that may have multiple buildings that they want to connect to a single internal portal. This is a pretty common setup for college campuses or business parks. Any place that has many buildings and with a single owner. One useful benefit is that our public portal, or LiveSpark, can cluster with this customer portal, providing a single point of access through LiveSpark to all the customers' buildings. And this is basically a cluster to a cluster approach. Next, please. And lastly, we utilize edge devices to provide analytics for places that are very difficult to get to. We have 2 edge devices or edge instances installed in facilities on Antarctica, one of which is at the literal South Pole. These edges are clustered with a customer portal in the United States and is connected intermittently via satellites. Intermittent is the key, as the South Pole instance, it only has maybe 12 hours of connectivity every day, and that window shifts over time. The US portal is the primary means of user access to these Antarctica-based devices. We use Replication to ensure that the US portal maintains an always available copy of the on-ice projects. And so the people in the United States can access the on-ice data even when the satellites are dark. So some precautions, some best practices when deploying edge devices. Placing edge device hardware closer to the metal improves data reliability, but it doesn't necessarily eliminate hardware and network issues. These devices are still running on computers, and so you still have the same problems with any server hardware. Resolving issues, technical issues on edge devices can be difficult, especially in instances where the device is geographically or physically remote. For instance, I've never been to the South Pole. I really hope not to. Next, please. Probably the most common issue is power disruptions. Surges, outages, brief flickers can bring an edge device down. Easy ways to resolve that is by using a battery backup, a UPS battery backup that costs maybe $50 at Office Depot, something that can provide power for a short period of time if there's any interruption in power. An easy alternative, if you don't have $50, is to use a spare laptop computer to run your edge analytics and utilize the laptop's battery. If you have a 5 nines reliability requirement, you could utilize automatic transfer switches to provide power from multiple power sources. So if one power source goes down, the ATS switches over to the backup power source. One key thing to keep in mind is to set your edge device's hardware to power up automatically when it is plugged into power. This is usually a BIOS setting, and you want something in place so that if there's a long power outage that outlasts your battery backup's energy capacity, you want your edge device to power back up when the power is restored automatically. You don't want to go out to the site to do it by pressing a button. Hand in hand with that is to make sure you run your analytics platform as a system service with automatic startup. So that way, when the edge device powers up, your analytics platform also starts up. Next, please. You also have to consider network failures because an offline device is as bad as a powered down device to a cluster. If you can't reach it, you're in the same boat. So one somewhat common problem I've encountered is with other newly added devices in a network piggybacking over your edge device's IP address. So if your edge device has a static IP address, make sure it's documented with the IT staff so that they are aware that you are using this IP address. Otherwise, troubleshooting duplicate IP addressing on a network is very tricky. Use DHCP, dynamically provided addresses if available, because edge analytics oftentimes they don't need a static IP address. They just need connectivity with the network where it's getting its data from. And if you have a 5 nines requirement, you can deploy redundant switches where you have a single device connected to 2 different switches that provide access to the same network. In order to deploy this approach, the switches have to utilize the spanning tree protocol. Switches that have that typically are more expensive, Cisco Catalyst level hardware. It's usually hundreds of dollars rather than tens of dollars. But that's that backs up your network. Lastly, you want to back up your backup. In the event of catastrophe, you want to have a means of recovery. In my previous role, I was assistant administrator, so ensuring I had an offsite backup was a very important job. Nicely, using the replication feature in a cluster makes this job easy. If you have a cloud-based cluster that you connect your edge device to and you use cluster replication, well, there is your backup in the cloud, your offsite backup for your edge device. You also want to make regular backups of your project locally. Usually this is a scheduled job where it takes a zip file of your backup. If you do that, You also want to make sure you clean up your older backup files, because over time, if you leave your stale backups in place, it will fill your hard drive, and then that's a big problem to deal with as well. And lastly, it's a good practice to set up tread logs for vital points in your controls system as a secondary means of point history. So if there's any issues with your edge analytics device polling a certain controller for its point data, you have a second source of that point data that you could query and retrieve that data. Caveat is, if your edge analytics has an issue connecting to a controller, the control system also is likely suffering from that same issue. But it's a good secondary means of backup for the point history data. And thank you, John.
Thanks, Sherry. All right, well, Matt, join us next and talk about some projects you've done and different ways you are implementing distributed architectures and edge analytics.
Thank you, John, and everybody for having me. I'm Matt SCHWARTZ, Associate Principal with Altura Associates. For those of you that don't know us, our mission is to implement projects in commercial buildings that save energy, improve comfort within the buildings, are lowering maintenance costs along the way, and generally providing a better environment for all of us as we live and work and breathe in all sorts of different types of commercial buildings. To us, we are a data-driven firm, and we use technology heavily to make sure that we are getting the results out of the implementation recommendations that we make. We're very much doers in the space as well as consultants. So with that, I'm bringing a singular example to the table today, and I want to go down into the weeds on it. So I'm bringing an example of a large campus of buildings that has a centralized yet distributed compressed air system, where there are many compressors spread out across the campus, but sharing distribution piping, very complex, very hard to track down where problems are. And we knew from working with our client, this was a target for energy savings. And we put together a project with folks from this panel, actually, to strategically go in, measure, monitor, find the problems, and fix them, and measure what were the results of that afterwards. To illustrate this example, I want to go back to BAS and Analytics 101. You're looking at an image on the screen right now that I think I'm trying to convey the many different layers that can exist in a BAS stack. And a question you might be asking yourself, looking at these 4 common layers of BAS, is where do I put analytics now that I can put them at the edge? There's different places to put these things. Do I put them at the building supervisor here? Do I put them in my field controllers here? Do I put them down in the device? Should they be in a central server if they're also spread out across my distributed architecture? And oh, hey, now BAS platforms offer analytics. Should I put them in my BAS? There are a various list of places you can put these. My answer to that question is not straightforward. It depends on the project. So if we go to the next slide, you'll see that our recommendation is to take a strategic approach at deciding, where are you going to put this distributed privilege of analytics? Where do we put that? And for this project example, if we advance twice, then I will indicate that we're putting them here at the central server level, as well as in our field and our edge controllers for this particular project. It may vary for your project. One more click, John. And a couple more. There we go. So for this project, we're going to use a campus analytics server. We're going to use an analytics embedded IO controller, courtesy of ALPER, who's on the panel here. The analytics we used was SkySpark Analytics. And then we bought generic pressure and flow sensors and tied those to our IO controllers and went in and strategically picked monitoring points across the campus to measure power, flow, and pressure of this compressed air system. So the results of that were we were able to look at data and analytics granularly down at the pressure or the power meter or the flow meter, and know for any one spot on the campus where we dropped one of these things, what was going on. But we could also aggregate that data and look at it big picture in our central server. So the combination of those two let us do all the things I said we would do in this project. Find the problems at the granular level, analyze it at the big picture level, and get data like this. So now you're looking at data coming right out of an edge controller, running analytics, and through engineering, and we're not taking people out of the equation here, engineers at Altura studied this data using analytic rules to find things like this. You're looking on 316 at a compressor leak that we identified because the compressor was operating at higher points than we expected. So we drilled into that location. We didn't look at every single compressor in the campus. We used data, got smart, went to this one and found the leak. Once that leak was fixed, as you can see the traumatic drop in the data, we found 13.7 kW a reduction on this one compressor alone. Next slide. Another look at some edge data. Now this one's kind of fun to look at because this is flow, and this problem presented itself because looking at the average flow here, we realized that we were operating slightly above where we thought the demand of the devices pulling compressed air off this system should be. And it was a small change. We did find a leak, we fixed it. And you'll notice it only dropped from about 86 CFM to 82. But that runs 24/7 and resulted in a 1 kW drop. We therefore found several other compressors doing a similar thing. And by fixing these small leaks at scale across the campus, we could find the small leaks at the edge, fix them, and analyze big scale, full scale, what was the savings of that? And so those add up when you get these little 1 kW hits and do it at campus scale. And that's just one example. So next slide. Now, those of you with a keen eye are going to notice that this is different data from another project, and I apologize for not inserting the right slide here, but this still drives home a great point. At the central level, now we're going to move on from finding leaks and issue detection granular to the equipment and say, I need to show my client what we projected and what we did. And we can do that with the central analytics now. So we pull all the power data from the granular analytics, and we use the machine learning that's built into our analytics platform to take the baseline data, forecast out what would have been, and then apply to that the what was aspect of it. So we can show three things here. Where was our baseline? And carry that baseline out, even though that's not real. And then show, here's what we predicted when you signed the contract that said this project would return you money. Oh, and here's the actual where we're beating that predicted. Next slide, John. And then lastly, just want to show that this is a real project. It cost the customer $45,800 to do it, and it delivered close to $290,000 over 7 years once we took into account incentive. And this is with no escalation, but all of the leak repairs and issues that we fixed translated to, I think, about a $31,000 reduction in electricity costs. Add that to the incentive, and this was less than a 1-year payback project. And now those systems are installed and they're still collecting data to this day, and they flag us when we find a new leak. So now we're getting the persistence out of it as well. With that, I'll hand it over to our next presenter. Thank you for the time.
Hey, thanks, Matt. So next, ALPER will present examples of actual hardware to run analytics and control out at the edge. So ALPER, I'll turn it over to you.
Okay, thank you. My name is ALPER ÜZMEZLER. I'm the manager of BASSG and the founder of Anka Labs. Over the years, we worked with basically Matt, and it actually all started from that air compressor project, pilot project. So it's all Matt's fault. Next slide. With the technology changing, the IT architecture also changes. So we are moving away from serial buses going to direct IP devices. Also, the technology on the hardware is enhancing, and the price of electronic boards are dropping. So this allows us to think about how we deploy devices and what we can do with them. basically what we have done is what we decided is to put the analytics all the way to the edge. Next slide, please. So the data flow changes too, because we don't have microcontrollers anymore, only microcontrollers where we aggregate data in gateways and supervisors. Now we can actually do all of these within the application. So we can control, historize, we can do the analytics within the device, we can connect all these devices together within the cluster system that John talked about. And also we can visualize and ask questions to the cluster by leveraging Project Haystack, which is semantic data model, and that creates a paradigm shift on our industry. Next slide, please. Application types, exactly what Matthew actually demonstrated. We have done the airflow monitoring. We have done a rooftop unit system, variable air volume boxes, and indoor air quality sensors. So the application types aren't limited to a single system. You can think out of the box and apply this distributed computing anywhere that you might see fit. Next slide, please. So the workflow of a new era distributed computing is that you control, historize, analyze, and cluster and visualize and ask questions. It's kind of replicated to the last slide. So next slide, please. All right, so basically by leveraging the clustering technology, we were able to create a system where we can update controllers within that secured WebSocket system. Also, you can actually apply your changes to a certain code, given that it can be a controls logic, or it can be the analytics rule that you defined. We are able to, within our system, we are able to upgrade and update with a single click. Next slide, please. Within this system, we have real-time programming layer, which we open source that I will mention within the next slides. We can actually do those programmings through the clustering as well, given that Brian Frank gave us APIs and we were able to program the real-time logic through clustering. We don't even have to know the IP of the device, where it is installed, how it is hooked up. We just go in there and start programming it. Next slide, please. All right, so talking about hardware agnostic controls, we created Project SenStar and open sourced it. Next. So the existing systems are built on proprietary and old technology. And within the new era, next slide, please. What we have done is hardware agnostic controls. By merging two different projects, we were able to achieve it. Next slide, please. Within the current system, you cannot share your controls logic between different devices. This is why we open source Project SenStar, and we have written SenStar Web Editor, where you can actually program the device through browser. And we basically, by doing that, we don't have to worry about Sedona frameworks kit dependencies. Next slide, please. We basically chosen two different technologies written 10 years apart by Brian Frank. One of the technologies called Project Haystack, and Haystack is to create semantic data model and to do analytics and also digest data. We moved it all the way down to the least common denominator, which is the controls, and we open sourced it so that we can do a lot of things a little bit more automated. Next slide, please. So by having Project SenStar exposing as Haystack, we can create graphics, we can do analytics, we can consume the data on mobile applications right within this architecture. Next slide, please. So in order to achieve all these, we had to build hardware as well. And we worked with our partners within this model. So we have a variety of different devices that has analytics built in all the way at the edge. Also a gateway. Next slide, please. when the COVID has started, we have open sourced all of our hardware design for the indoor air quality sensor, also the project SenseStar, so that anyone can build these indoor air quality sensors and read data out of them via Haystack. Next slide, please. We are also working with a company named Redaptive where an analytics engine is bundled within the device where you can analyze and write back to the BMS systems to do demand and response. Next slide, please. So overall, the architecture changes within the BMS systems where you can consume data on your mobile phone, you can do real-time control logic, you can do your analytics all within this clustering platform. Thank you.
Thanks, ALPER. Thanks for showing the hardware examples that making this a reality out in the field. And I guess at this point, Sam, we'll allow you to come back in. Hopefully we have some questions from the audience, and we'll be glad to have different members of the panel try to address the questions.
Wonderful. Thanks all. And just a quick reminder to our audience, if you have any questions, please go ahead and submit those to the Q&A button so we can address them. First question is the edge replication require that there is a complete digital twin of the building system?
I'll jump on that one quickly.
Okay.
No, what we're talking about is replicating the data available. And I think that's a really key point. I mean, if you can have a true comprehensive digital twin of everything in a facility, that's great. I think that's viable in new buildings. What about existing buildings? What we're talking about replicating is replicating what data is available. The sensors you have, the meters you have, the control systems you have, what you're providing analytics on, and then replicating that entire, and again, operating database to other locations that can be on premise or in the cloud to give other operators full interactive access, even when the end system may be offline, like that great example that Jerry has, right? It's a guaranteed that Antarctica is going to lose satellite communications for a good portion of every day. But the people doing analysis on all the data, they work with the last replicated information.
Thanks, John. Matt, maybe you can enlighten us on this question that you kind of answered. What are the security concerns and how are you addressing those concerns?
Yeah, I'd love to. I would encourage everyone to think about security as a system rather than as any singular device or piece. So that said, you really should have security in mind from day one and be looking at the device itself. What features and security does that device allow? A lot of times that's authentication. You should have authentication evaluated and reviewed and make sure these devices at a basic level have that. And I'm sure these guys can go deeper into what the device itself can do with onboard firewalls and boot security and all that good stuff, but it should not stop there. There should be a discussion had with your cybersecurity teams, especially if this is going on your IT network, where you can find a lot of savings if you can do that well, and be thinking about port and protocol management, firewall management, the actual architecture of how these devices are connected to your infrastructure and your switching gear, manage switching. And then if this is going to leave a building and go to a cloud, what ports and protocols are we managing there? What traffic are we allowing? All of that really needs to go into the cybersecurity soup at the beginning of any project where you're going to implement this stuff. And everybody should be bought in and be talking the same vernacular so that you can reach the highest level of cybersecurity. Somebody showed me a really great graphic, just a funny cartoon the other day of all the firewalls and switches in the world stacked up in one corner of a boxing ring and human error in the other. And human error is going to win every time because it doesn't take much to make a vulnerability. So the more you can take a 360 approach to cybersecurity, the best. And that happens when you bring the right stakeholders to the meeting day one and design it in.
Great. The next question, what challenges are there in calibrating sensors required for your data quality?
Finding someone who knows how to do it.
Um, I'm working on a project right now, and I'm not sure. I'm having issues not with the sensor calibration, but with meter calibration. So it's kind of similar, but honestly, this is a pretty common problem where electrician installs sub-meters, but they don't apply the scaling on the meter, or the meter's units are completely out of whack, or the values are out of whack. There's not a lot of commissioning done on meter data itself, and that's my biggest. That's a lot of my work right now is using SkySpark to identify and basically commission these meters that should have been right the first time when they were installed. But it's to resolve it, you document it, you show the values that are coming in, you show the amount of usage, you compare it with other meters, and usually it's pretty clear. Sometimes you'll see main meter data that is less than sub meters under it, and that doesn't make any sense. I use SkySpark or Edge Analytics as a tool for showing these issues and getting the right people to fix them.
I would just add, Jerry brings up a great point. The best meter installers out there know how to check the CTs and put an amp clamp on and make sure that the readings coming out are right. We don't always get that in our new projects. So one thing you can do for new projects from a commissioning perspective is write into your specs, your BAS specs, your electrical specs that specify the level of calibration you expect, and ask for that documentation as a part of your project work, or your commissioning authority could be asking for that level of documentation for new work.
So I have a question specifically for Jerry. How do you manage monitoring all those remote node statuses and connectivity?
That's a good question. So we have our analytics platform, SkySpark, gives you the ability to write rules that identify any issues that you want to keep tabs on. And we have rules written that checks on the health of the connectivity, the connection between each cluster. And we get notifications when the connectivity is offline for X number of hours. It's analytics.
So I'm not sure what slide this was, but someone's asking what software platform was used in presenting the analytics results as those demonstrated in some of the slides.
For the compressed air results, those were screenshots from the SkySpark analytics platform.
Okay. I see ALPER typing the answer there. Another question that just came in the HVAC industry, are there quite a number of analytics users now? What do you guys think? And this person's specifically addressing this to Matt, actually.
More and more. I can tell you from our perspective as BAS and building science experts, we don't do a project without analytics anymore. And we are seeing that uptake across our peers in the industry. We are seeing our clients adopt analytics as core components of their commissioning programs. And this is multiple clients. We spend a lot of our time now helping the industry understand how, where, and when to use analytics and how they can accomplish their goals and visions. So I think analytics is here to stay is probably the best answer to your question, has demonstrated its value.
Okay, next question is about air quality. What air quality readings are you taking and what ML is used to learn from it?
I answered it. I'll answer it here as well. It has PM1, 2.5, 10, TVOC, CO2, and temperature. And the platform has a SMILE library for machine learning applications. So you could utilize, if you have occupancy count one way or another, you can predict what the CO2 readings could be or other readings could be.
Perfect, thank you. And John, did you want to just address the clarification about SkySpark?
Yeah, I did type an answer, but just to address that, SkyFoundry does not host software. We make software, and that software can, as we've been showing here today, be deployed on the cloud, on premise, and at the edge. The same exact software and functionality runs at all levels, supports all the operating systems. So it allows people to create distributed multi-node data collection analytics solutions that address a lot of the problems and challenges that the different panelists talked about here today.
Perfect, thank you so much. So that's actually all the questions that we have today. So thank you all to the panelists for joining in and doing the Q&A with us. John, could you hit the next slide for me? Before we go, we just wanted to highlight that we do have another webinar coming up on improving air-cooled and water-cooled chiller performance and energy efficiency. You can go register at energymgmt.org. And then also, I see a lot of new faces here. You may be new to us. EMA is partnered with the AABC Commissioning Group and then also the Associated Air Balance Council to bring CX Energy Conference every year. We're virtual again this year, but we also have a dedicated technology day that may be of interest to you. I know SkyFoundry, and then also BASG is also participating. So please visit cxenergy.com to register and check out our technical program. Thank you all.
Thanks.